Okay, let's get into it. Today we're doing a deep dive into something that's really the hidden backbone of massive video operations. We're looking at a specific piece of hardware, the NTI SM-32X32-DVI-LCD. It's a DVI video matrix switch. So our mission today is to figure out what it really means to have a device that can manage 32 video inputs and send them to 32 different screens all at the same time. I mean, what kind of place needs that?
That's the right question. And the need is for, high-stakes environments. You can think of this as the ultimate traffic cop for video. Its job is to take signals from, say, 32 different computers or satellite receivers and route them flawlessly to 32 displays. We're talking giant control room walls, surgical theaters, that kind of thing.
32 by 32. That number alone tells you this isn't for your average office. And the routing flexibility is where it gets really interesting. Any of those inputs can be sent to any of the outputs, right? Or even all of them at once.
Exactly. Any or all. And with that much going on, you absolutely need simple, robust control. So you can run it over a network, using standard stuff like TCP/IP, which is perfect. But you also have local access buttons right on the front, a serial port, even an IR remote.
And when you're pushing video to that many screens, you have to worry about the quality holding up. How does it do on resolution?
It's solid. It handles all the standard HDTV resolutions up to 1080p, and for computers, it goes all the way up to 1920 by 1200.
That 1920 by 1200 WUXGA, that's a bit wider than full HD.
It is, and that extra space is critical for displaying dense data on PC monitors. It keeps everything sharp thanks to the pure DVI-D digital interface.
Okay, so here's what always seems like the biggest headache in these setups.
You say?
Compatibility. How on earth does it stop 32 different displays from just, constantly having issues?
It's a feature called EDD learning. It's essentially a digital handshake. The switch automatically talks to each display, figures out the perfect settings, and just locks them in. It even has default tables for PC and Mac built in, just in case.
That's smart. Now, I saw something that seemed a little surprising. It's a DVI switch, but it can handle HDMI. How does that work?
Yeah, that's a great feature. If you use a specific DVI to HDMI cable, it actually passes the full HDMI signal through the port.
So video and the audio.
Video and the embedded audio. It just passes right through. It adds this whole other layer of adaptability. And if you look at the other specs, like TAA compliance for government use and its immunity to electrostatic discharge, it's clear this is built for mission-critical work.
Built to survive, for sure. Which brings us to another wild feature, the range. For really big installations, you can use this with fiber optic extenders to push a signal up to, what was it, nearly a mile away?
Almost a mile.
Yeah.
4,920 feet. Think about connecting one end of an airport to the other or buildings across the campus. It's a huge distance. And they even streamlined that. There's an optional model of the switch that can power those local extenders itself, so you don't need a separate power supply at every single display.
That's incredibly practical. And for infrastructure that spans that kind of distance, uptime is everything. Which brings us to the MTBF.
The mean time between failures. For this unit, it's 35,727 hours.
35,000 hours.
To put that into perspective, that's over 4 years of it running 24/7 without a break before you'd even expect a component to fail. At the end of the day, that's what this thing is. It's a specialized, super adaptable backbone for systems that need range, routing, and just absolute dependability.
So considering this switch is designed to send critical video almost a mile away, and it's built to run for over 4 years without failing, it makes you think, what other unseen infrastructure is working right now in your own city with that same level of deep planning and reliability? From hospitals to our utilities, how much do we depend on these invisible systems every single day? Something to think about.